All right, greetings guys. I hope you are good. I hope you are well. We are starting with a new topic called sigma notation. Sigma notation. And when we talk about sigma notation, it is a way of writing a series in symbol format. That's basically what is sigma notation. So we have the following symbols that we use. We use number one, the Greek letter sigma, and the way the Greek letter sigma, it tells us about the summation. All right, it tells us that we must add whatever is given there. And let me write it this side, because I will need that side. So this is the Greek letter sigma, and it tells us about the summation. And then we have the general formula. Every sigma must be associated with a given general formula. We have the general formula. The general formula tells us about how is this series defined. And then we have the upper limit, which tells us about the last value. Very important, not the number of terms, but it tells us about the last value in the given series. And then we have the Greek letter, we have this letter I, and for now I will say it is equals to m, and it tells us about the first value. All right, the first value. In other words, where does our series begin? And this one tells us about where does it end. This one tells us about how is it defined, and this one tells us that we must add. All right, let's take an example to make it clearer to you. Example 1. I will say expand and evaluate. All right, so we have this is 7k equals to 1, 5k minus 3. Let's try to work on that. Now remember, this tells us that the first value where this thing starts, it starts at 1, meaning the first value that must be substituted here into the general equation is 1. Okay, first value that must be substituted into the general equation is what? Is 1. The last value that must be substituted into the general equation is what? Is 7. So this is the last value to be substituted. And where are we substituting it? We are substituting it into the general formula. And what must we do? We must add. All right, let's try to do that. So now we have a general formula here, which is Tn equals to 5k minus 3. So now this will be, if we calculate this and expand it, it's gonna be sigma upper limit 7, lower limit 1, 5k minus 3, where what is the first value that we must substitute? Well, into the general formula we must first substitute 1, then we substitute 2, then we substitute 3, then we substitute 4, then we substitute 5, then we substitute 6, and then lastly we stop at 7. Guys, I should note that if here it was 3, we are gonna start from 3 and say 3, 4, 5, 6, 7 and substitute those values. Okay, so it matters where does this begin. All right, it matters where does that begin. All right, so because it begins at 1, that's why we first substitute at 1. And if you say 5 minus 3 is just 2, 5 times 2 minus 3, it is just 7. 5 times 2 minus 3, it is just 12. 5 yes, here it's 3. 5 times 3 minus 3, it is just 12. 5 times 4 minus 3, it is just 17. 5 times 5 minus 3, that's 25 minus 3, which is just 22. And then 5 times 6 is just 30 minus 3, which is 27. And of course 5 times 7 is just 32. If you add all of this, you'll get 119. All right, I hope that made sense to you. Then we want to know, how do we find the number of terms in a given sigma notation? So finding the number of terms in a given sigma notation. This is the formula we're gonna use. We will say the number of terms, and I will illustrate this shortly once my thing revives. The number of terms is equals to the top value, which is the last value, subtracted by the bottom value, okay, which is the first value plus 1. Very important, guys, very important. Okay, the number of terms equals to the top value, which is the last value, minus the bottom value, which is the first value. Very important. Let's try to represent this. Let's say you have a situation like this. You are having n, you are having I equals to m, and of course you are having tn. If you want to find the number of terms in this, you will say the top value, okay, number of terms would be the top value, which is n, minus the bottom value, which is m, then you say plus 1. Okay, let us put that in example format. Let's say I give you the following example and say determine the number of terms in the following series. Now this series, you don't have to write it from scratch like you would write a sum. So let's say you have 8k equals to 0 and 2k. You don't have to write it as 1, 2, 3, 4, 5 all the way to 8. No, what I want you to do is that you use the formula. Remember, the number of terms equals to what? Number of terms equals to the top value. What is the top value, guys? It's 8 subtracted by the bottom value, which is 0, then that is plus 1. So 8 minus 0, guys, it's what? It's 8, and then plus 1 is what? Is 9. You see how simple that becomes. We want to deal with a situation now where you are given, in this case is when given the general formula as a constant, that is when Tn equals to C. The result will be C will repeat itself until the last value, and the values substituted will be raised to the exponent 0. Very important for you to understand. All right, so what does this mean? It means that if you have a situation like this, where you have n as your last value and m as your first value, but you are having c. All right, and let me write it this way. You are having your general formula being equals to c. What will happen is that c will repeat itself, but the value that you substitute will be to the exponent 0 all the way until you get to the last value. All the way until you get to the last value. All right, let's demonstrate that in an example. I will say to you, expand and calculate, and I will give you 12, m equals to 3 and 6. All right, where does it begin? It begins at 3. Where does it end? It ends at 12. Numbers in between 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the general formula? Tn equals to 6. Okay, so now we start. Well, we can ask a side question. How many times are here? Well, you would say to me 12 minus 3. Okay, what is 12 minus 3, guys? It is 9. I get it. 12 minus 3 is 9, plus 1 is 10. So there are 10 terms here. That's just to revise what you learned previously. All right. If I want to expand this will repeat itself. I will have 6, but this, when I substitute it, I must put it to the exponent 0. The number after that is 4. And that 4 must be placed to the exponent 0. The other is what? Is 5. That must be placed to the exponent 0. The other one is 7, placed to the exponent 0. The other one is 8, placed to the exponent 0. The other one is 9, placed to the exponent 0. The other one is 10, placed to the exponent 0. The other one, of course, is 11, placed to the exponent 0. And the other one, of course, is 12. Placed to the exponent 0. What you will notice here, guys, is that this is 6. All right, this is 6 plus 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 6 all the way to the last number. So the answer there would be 60. But somebody's asking there, is there a better way? Yes. Well, since I know that this thing is repetitive, what I can do here is that, okay, I know that this will be 12, m equals to 3 and 6. Of course, what I can do is that first I can calculate, if they didn't ask me to expand, okay, provided they didn't ask you to expand. Let's say they didn't ask you to expand and they just said calculate. Okay, first thing I would do is to find how many terms are here. Remember, number of terms would be the last term subtracted by the first value plus 1, which would be 9 plus 1, meaning there are 10 terms here. So if I want to calculate this, I would say sigma 12 m equals to 3 and 6. So I would say this is equals to what is the number that's repeating itself? It's 6. How many times is it repeating itself? 10 times, and that is equals to 60. Okay, that's how you would do that. All right, so let me perhaps put it in letters for those of you who always like it in letters. I will put it for you in letters. This will be n minus m plus 1, okay, and that is multiplied by c. And it will give us what the result of this sigma notation will be. Okay, I hope that makes sense. I want to give you the last one, a very interesting question. I'm not going to do everything. I'm just giving you bits and portions. So we'll give you this example. The last one. We will say write the following series in sigma notation. So I'll give you 2 plus 5 plus 8 all the way to 83. Notice this is a finite series. Okay, now what do I need for me to write something in sigma notation? Well, first I need the letter sigma to show me that we are adding, and then I need the general formula, which will be placed here. And then I need to know where does this thing begin, and then I need to know what is the last value. Very important. So it seems to me the first thing that I can do is to find the general formula, because if I can find the general formula, I will know what is the last value, and I will know where should it start. So the first step is to find the general formula. So step 1, find the general formula. All right, first you must ascertain what type of sequence are you dealing with. Well, we already see that this is arithmetic, so we'll use the formula. Okay, we have a being 2, and we have the common difference being 3. Then we use the formula, the one that I like. There's the other one that you can use, but I like this one. Tn equals to a plus n minus 1d. My first term is 2, and my common difference is 3, so that I have 2 plus 3n minus 3, so that my final answer is 3n minus 1. Is that okay with you? All right, so I have found what is the general term, so I tick that. Found the general term. Now I want to know what is the last value. Okay, so I will then take this general term, Tn equals to 3n minus 1, and say, okay, the last value, what will be the last value? What will be the last value? I put 83 here, equals to 3n minus 1, and then this will be 84 equals to 3n. Divide both sides by 3, therefore your answer will be 28. Very important, meaning your last value will be 28, term number 28. Okay, now we are on the right track. Now we want to know what is the first value, and the first value you will find it by trial and error. Okay, so I will take the general formula and say, okay, my general formula is what? Is 3n minus 1. Okay, what happens if I substitute 2, 1? Do I get this? Do I get 2? If I don't get 2, I'll substitute 2, I'll substitute 3, I'll substitute 4 until I get what the first value is. Okay, let's substitute 2, 1. So that is 3 into 1 minus 1. So that is 3 minus 1 equals to 2. And does it correspond with this? Yes. So meaning the first value is what? The first value is 1. So n must be 1. All right. Now let's write it in sigma notation. First, we are adding everything. So to show that we are adding, we use the symbol sigma. Okay. And then our last value is 28. Our first, it's not 2. We must first substitute 1. So we will say n equals to 1, or you can say I equals to 1. But remember, your general term must correspond with your n. If you're gonna use n, you must use n in your general term. If you're gonna use y, you must use y in your general term. Okay, so here now this is 3n minus 1, and that is how you write that in sigma notation. All right, you can do this as homework. Write the following series in sigma notation: 2 plus 6 plus 12 plus 20 to n terms. Okay, and see how you fare with that. All right, guys, I am done with sigma notation. I hope now you are having understanding.